Third problem related to Doppler effect of sound. A car is moving towards a stationary observer, emitting a 490 Hz sound wave. The beat frequency heard is 10 Hz. If the speed of sound waves in the air is 340 meters per second, what is the speed of the car? So in the problem, we are asked to identify the speed of the car, which is actually also the source of the sound in the problem. Okay, so first let's identify the given variables. First, we have the speed of the observer, and it mentioned here that it is stationary, which means the speed of the observer is 0. Next, the car is emitting a 490 Hertz sound wave. So this is our source of frequency, 490 Hertz. And the next statement is the beat frequency heard is 10 Hertz. So meaning this is the beat frequency heard by the observer. And the speed of sound is given in the problem, which is 340. For the required, we are asked to get the speed of the car. Okay. Now, to solve this problem, first, we need to get the actual frequency heard by the observer. So, all we have to do is just to add the beat frequency plus the source of the sound, which is 490 Hertz. So adding these two variables, we have now 500 Hertz. So this is the frequency heard by the observer. Okay? Now, we are asked to calculate the speed of sound. So, of course, we need to follow some of the basic rules, right? So, in our formula, okay, we have FO is equal to Fs times the quotient of B divided by V minus Bs, okay? So, first, our observer is stationary, so 0, so we just emit the 0 in the equation. Since any number add by 0, the answer is still the number itself. So, pwede na natin siyang tanggalin. Okay? And for the second variable, the car is moving towards the stationary observer. So, the rule is, if the source of sound is moving or approaching to the observer, we need to put a negative sign. That's why we put here minus the speed of the car. So this will be our final equation. However, we need to rearrange this equation because what we are asked is to get the final speed of the car. Yung Vs yung hinahanap po natin sa problem. Therefore, we need to rearrange the equation. First, we can put the Fs as a numerator below the Fo. And then afterwards, we can put a cross multiplication. So, FO times V minus Bs. So, this will be the actual equation. Fs times B. This will be our equation for this. Now, the next thing to do is we can distribute FO. No? Can multiply it since there is a parenthesis on this formula. So, applying the distribution, FO times V, and then FO times Bs. So, you have here minus FOVS. Okay? And since we are asked to get VS, we can transpose FOV on the other side. So, this will be now our equation. And lastly, we can factor out this component since they have the same value of speed of sound, which is V, which means this will lead to our final formula. Vs is equals to Fo minus Fs times the speed of sound divided by the Fo, or the frequency of the observer. Okay? So our last step is to substitute all the values. For Fo, we have here 500 Hertz. For Fs, we have 490. The value of our speed of sound in the problem is 340, and all over divided by the observer frequency, which is also 500. Okay? Now, when we use our calculator, plug and chug the values, we end up with 6.8 meters per second. Okay? So, this will be the final answer. The speed of the car is equal to 6.8 meters per second.